The position of a particle with respect to time is given by the function s of t equals t squared plus 3t plus 4. We want to find the velocity of the particle, that is the instantaneous rate of change, at t equals 5. So recall that our formula for instantaneous rate of change is the limit as h goes to 0 of our function, which in this case is s, of t plus h minus s of t over h. And now we're given that our t value is 5, so we're going to plug that in. So we get limit h goes to 0 of s of 5 plus h minus s of 5 over h. Let's calculate these two pieces, s of 5 plus h and s of 5. S of 5 plus h will be 5 plus h squared plus 3 times 5 plus h plus 4. Recall that 5 plus h squared means 5 plus h times 5 plus h. And then here we can distribute the 3, so plus 15 plus 3h plus 4. Expanding this, we get 25 plus 10h plus h squared plus our other terms, 15 plus 3h plus 4. Combining terms and writing them in order, we get h squared plus 13h plus 25, 15, and 4 is 44. So this expression gives s of 5 plus h. Let's also find s of 5, which is 5 squared plus 3 times 5 plus 4, which is 25 plus 15 plus 4, which is 44. And now we can plug these two values or expressions into our instantaneous rate of change formula. We get the limit as h goes to 0 of s of 5 plus h we found to be h squared plus 13h plus 44 minus s of 5 we found to be 44 over h. When we simplify, these 44's cancel out. We get the limit as h goes to 0 of h squared plus 13h over h. And we're going to factor out an h in the numerator. That gives us h times h plus 13 over h. That way these two h's cancel out and we get the limit h goes to 0 of h plus 13. At this point we can plug in 0, we can evaluate the limit and get 0 plus 13, which is 13. And that 13 is our instantaneous rate of change, or our velocity of the particle at time t equals 5.